Okay? There will be a homework problem based upon that. Now let's take a look at the second example for this. It says the reaction ozone plus NO2 yields O2 plus N2O5 is actually the result of the following elementary reactions. And these are the two elementary reactions. Now I'm going to put this on the board as well here. So you can look at your script later on or just follow along on the smart board that I'm using right here. So for this right here, again we're dealing with ozone, which is gas. These are all gases. Plus NO2 gas. And this is going to, this is the first one, rather. This is the first step. Gives us NO3 gas plus O2 gas. And it turns out that this is a slow reaction. It's a slow reaction compared to the second one, which actually takes that NO3 that's created over there. That NO3 then turns around and collides with an NO2. And it creates N2O5. Dinitrogen pentoxide, if you recall that compound. This is nitrogen trioxide, nitrogen dioxide, nitrogen, or this element, this is ozone, that's elemental oxygen over there. And so the question is here, what is the overall reaction? What is the rate law for that reaction? And what is the molecularity for this reaction? Okay, so, and this, by the way, we said is faster than the other. Now, the overall is the sum of these two reactions. So, we're going to do like we do in algebra. We have something on either side of the equal sign, and in this case, the yield sign is the equal sign. We're going to cancel them out. So, we got an NO3 here, and NO3 here. And that looks like the only thing we have in common. So we bring these together. We got O3 gas plus, now notice we have 2 NO2 gas yields N2O5 gas plus O2 gas. So this is the overall reaction. This is what we see at the end result. Now, what's important about this is that when we find the rate law, it's based upon the rate determining step. And this is the rate determining step. Right here. Why? Because it's slower than this right here. And so the rate law is going to be dependent upon that particular step. So this is going to be concentration of O3 to the M power. Well, the exponent here is 1. And we don't need to put a 1 there. But I'll put it there to start with, and I'll fix it just a little bit. Times, not plus, times NO2 to the first power. And, oh, I forgot the K here. Really need to put that K in there. And so, that's the beginning of it right there. So R equals K, and that should be a lowercase k, concentration of O3 times the concentration of NO2. So there is our rate law right there, based upon step 1. Now, we notice here that we have 2 molecules, so this is a bimolecular reaction. Also, we notice here that we have, we have the NO3 that was created and then turnaround was absorbed with this NO2 or react with the NO2 to create this N2O5. So it doesn't even factor into the overall reaction, and it doesn't factor into the rate law. But it happened. So we have a word for compounds that were created and then used up, and that is an intermediate. Now, what does that mean? Well, remember when we did this chart here where we had energy here, we had time of reaction here, and we had this thing here, we had this thing here, and then we had this plateau, like so. That compound that's created at the top here was the NO3, which turned around and reacted with this real quick like that. So in effect, what we should have seen was just like a little bump more here. Because we actually had two reactions going on here. So in effect, this is being created, and then drop, and then up, and then back down. Something like that. And there's your product right there. Reactants and products. So that hump right there is where the intermediate is created. That compound had to be made in order for this reaction to take place. If that doesn't happen, then it doesn't go. Well, and we said it's slow, which means it had a really high activation energy. That activation energy right there is what caused it to be slow. We have a very tiny activation energy right here, and that part was going to be fast. So when you have a two-step reaction, you actually should have two sets of humps. Okay? All right. So, your homework. Page 643, problem 70 through 76 here. Good luck.